we're going to look at the other type of improper integral. That's the one where one of the limits of integration is infinity or negative infinity. And technically, both of the limits could involve infinity, but we're not going to look at any of those. So this one's improper because the infinity, you might note that there's an asymptote on this function, an asymptote at 0, but that's not on the interval, so it's improper because of the infinity. And same thing over here. There would be an asymptote at 0, but since that doesn't fall in the interval, then that's not the part that concerns us. So the question we're really trying to answer is, what's the area underneath this function on this interval? And your first thought might be they're both going to be infinite areas because we're extending the x all the way out. But one's going to converge to an actual limit, and the other one's going to diverge. Let's go ahead. To do both of these antiderivatives, we first need to bring it up. So we can apply power rule. So I bring it up as x to the negative 3. I'm going to add 1 to the power, divide by the new power. You've heard me say quite a few times I don't like to substitute into with a negative exponent. So I just moved it up. I did my antiderivative. Now I'm going to move it back down. Take a moment to observe what I've done here. Now I'm going to substitute a really large number since I can't substitute in infinity. So a really large number squared, really large number, times negative 2, all that over 1. So essentially I have 1 over a negative really big number. One piece out of trillions and trillions of pieces. When I think of that in limit terms, that piece is going to approach 0. And then I'm supposed to take this and substitute my 3 in. Well, 3 squared would be 9 times negative 2. So this is going to give me, where was I? 9 minus negative 2, negative 18. Subtract the negative. This area converges. The area under the graph on this interval is, got a little messy there, that's 1/18. Now on to this one. That's really x to the 1/3, but when I bring it up, I'm going to have, that's 1/3 in the denominator, so it's going to come up as negative 1/3. I apply power rule that says add 1 to the power, divide by the new power. So negative 1/3 plus 1 is going to put me at x to the 2/3 divided by 2/3. And officially that's 1 divided by 2/3, which if you were to type that in your calculator, you multiply by the reciprocal. If you want to do it in your head, that gives us 3/2 x to the 2/3. And now we're ready to substitute in and see what happens. I'm putting in a big number. Well, this would say a big number to the 2/3. If you break that out, that's saying a big number squared and then to the 1/3 power, which cube roots it. But it's still going to be a really big number, because if you square root or cube root a really big number, it's still a big number. Times 3/2, that's a really big number. Now I need to substitute my 1 in there. Well, 1 to this sort of power is going to give me 1 times 3/2. So I'm going to have infinity minus 3/2, which really just means infinite. So this one has an infinite area, while this one had a area of 1/18. And when the area would be infinite, we say that diverges.